Today we're going to learn about the reciprocal function or the hyperbola function. So to begin with, let's start with the general equation y equals 1 over x. So y equals 1 over x, when you plot that on a graph, you get these shapes called hyperbola. And what happens is the graph itself gets closer and closer and closer to the x and y axis, but never ever reaches it. And when it never reaches it, what we say is that that line that it never reaches is called an asymptote. Now that's called the x-axis, which is when y equals 0, and the y-axis, which is when x equals 0. And these are the two equations of the asymptotes, which is basically where the graph will never ever touch. Let's talk about the domain and range of this particular graph. The domain, remember the domain is all the x values that work for this function. Every single value of x in the real number system works for this except 0, which is actually that asymptote. As a hyperbola graph moves around and those asymptotes change, then you're going to have to be careful about working out what that particular domain is, because it's dependent on the equation of the asymptote. So for this particular thing, that domain we would write x belongs to all real numbers except 0. Okay, so except 0. Now let's have a look at the range. Similar scenario for the range. The range, y, remember that's all the values that work for y, belong to every single number in the real number system except 0. So we would then write that the range is r but not 0. What I'm now going to do is talk to you about, well, what happens when the hyperbola is not central to the origin. So it's shifted horizontally, vertically, or possibly had a dilation factor. There is a general equation which you might be familiar with if you've looked at my function notations video. So we can say that the general equation for any hyperbola is a over x minus h plus k, where a is that dilation factor, so how much it's stretched from the y or the x-axis. H and k give us the equations of the asymptote. How much has that moved left? How much has it moved up or down? Now what we're going to do is I'm going to show you how to sketch these graphs. If there is no horizontal shift and no vertical shift, your equation is going to look like this, where A is the only thing that has changed, the dilation factor. Now if you have a scenario where there is no horizontal or vertical shift, you're going to have a graph that looks exactly the same as 1 over x. And in a sketch, how do you tell the difference between a 1 over x and a one that's had a dilation factor? Because with these kind of equations, it's going to cut the x and y intercept. You're going to have other equations of asymptotes, but this one, you're not. So what you really need to do is make sure that you give a coordinate on your sketch and work out an actual coordinate and list that on the graph to say, so that the examiner or the teacher can tell that you have understood that there is a dilation factor. Now, just before I go straight into an example of how to sketch and just stating the changes of this, I just want to write down what the general movement would look like. So the dotted line represents those asymptotes. So this is the horizontal asymptote. Now that's affected by the line when y equals k, and this line here is that change horizontally, so that's affected by the line when x equals h, and the shape of the hyperbola is just the same as that. Now, so you can see here we've got some y and some x intercepts there. So let's have a look at what the changes are. So let's just have a look at what the changes might be for this particular equation. So I'm just going to write a graph. I'm not going to sketch this one, but I'm just going to talk about what's happened from the original 1 over x to these. So let's have a look at this. As we can see here, we've got x minus 2. Don't forget this is minus h, so we need to change the sign. So that tells us that our value of h is 2, and our value of k is 4, and our value of a is 2. This means that the graph from 1 over x has shifted in the x direction 2 places in the positive direction, and has shifted 4 places in the positive direction on y, and there is a dilation factor of 2. So if I sketch that quickly, Now, true sketch, this isn't going to be a true sketch because we're going to need to find the x and y intercepts, which I'll do in my next example. But roughly, it's going to look like this, where you must always give the equations of the asymptote. So this one is y equals 4, and this one is x equals 2, and then you've got more lines like that. So you must give these coordinates here. I'll just give myself some more room and we'll work out what those coordinates are. So in order to do a sketch, you must put the headings, and the important key headings, there's always 3 headings whenever you sketch any graph. The first one is always the x-intercept, which occurs when y equals 0, and I generally put all my working underneath. The second heading is the y-intercept, and that occurs when x equals 0. And the third heading is always that value of hk, which in this particular graph represents those equations of the asymptotes. Hk is always a useful one with any kind of transformation that you're looking at, whether it's a parabola or a cubic or the hyperbola. So we already know, because we've written those down, that when h is 2, the equation of that particular asymptote is x equals 2. And so therefore, because k equals 4, the equation of that asymptote is y equals 4. Let's have a look at the x-intercept. So for this one, I'm going to substitute when y equals 0. So we get 0 equals 2 over x minus 2 plus 4. Subtract the 4, and then multiply this and over there and remove that one over there. So you've got x minus 2 equals 2 over minus 4. Working that out gives me that x equals minus a half plus the 2, which tells me that x equals 3 over 2, or 1.5. Okay, so we've now got our x-intercept, which here is 3 over 2. Now you do a much bigger graph, my pen's a little bit thick to show on here properly, but you can do a much better job than me. So now I'm going to go and find the y-intercept, and that occurs when x equals 0. So we place that in there. We've got y equals 2 over 0 minus 2, which is minus 2, plus that 4. 2 divided by minus 2 is minus 1, so we've got y equals minus 1 plus the 4, so y equals positive 3. So we now have our y-intercept, which is 3, and that makes sense because the asymptote just above it is y equals 4. So we know that that's a pretty reasonable answer. And that's pretty much everything you need to know about the reciprocal function and how to sketch those particular graphs.